Okay, so up to now we have two kinds of reflections. We haven't looked at the third kind. The two kinds we have are if we have some kind of a function here. When you reflect over the x-axis, it's called a vertical reflection. So don't get that mixed up. Reflecting over the x-axis is reflecting vertically. That's what happens when you change y equals f of x to negative y equals f of x. Or you could write it as y equals negative f of x. But the key is that the negative is after the function, outside of the function. Right? It's not inside with the x. You apply the negative after you do whatever the function says to do. This particular function is just square root of x. So this would be, pick a value, like to get this, you take an x value like 4, and you take the square root, you get 2. If there's a negative afterwards, it reflects that point down to this point, right? Down there. Okay, if you apply the negative after you do the square root. Okay, so that's a vertical reflection. When you put a negative outside there, it reflects over the x-axis. If you do not the opposite, but if you do something before you even do that, if you want to reflect over the y-axis, that actually what you need to do is apply a negative before you apply the function. For this, if you want the curve to be on this side, you need to have all these negative values rather than all these positive x values. You need to start with negative x values. But you can't, for this curve, it's a square root function. You can't take the square root of a negative. So if you want the curve to be over here, what you can do is put negative x. Negative x means just take whatever you have as a x value and change its sign and then apply the function. Alright, so if you take negative 4 and you change its sign to positive 4, then the square root of that is 2, right? That's how you get this point here. You can have the square root of this as long as you're changing the sign, and that's what that negative inside there. If you replace x with negative x, you get whatever would have been on this side ends up on that side. Right? So a point that was here ends up being on this side. The x value changes sign, but not the y value. The coordinates to this point are 4, 2. The coordinates to this point are negative 4, 2. Alright, whereas if you do the other reflection, and I keep doing that, if you do the other reflection here, this one, the points, the y coordinates change. That's 4, 2. This becomes 4, negative 2. The y coordinate changes. If you reflect this way, the x coordinate changes. Alright? Even if it's some other kind of a function here, get rid of all this. Let's go back to that. Let's use this other function, except you'd figure I'd learn that by now not to do that. If we do this function, this is the thing that people have a hard time. If somebody says do a vertical reflection on that, if you replace x with negative x, that's fairly easy. Except I keep doing that wrong one there. Well, that's a vertical reflection. I was thinking of this one. Replacing x with negative x gets you that side, right? All the positive y values become negative. If you reflect it vertically, if you replace y with negative y, all the points switch sign. It isn't that you reflect at this vertex here. It's not going to be down here. If you have a point that's got a positive y value, it becomes negative. If you have a point that has a negative y value, it becomes positive. If you have a point that's on the axis, it stays where it is. It doesn't change places because it's 0, right? If you change the sign of 0, it's still 0. Reflecting vertically over the x-axis, reflecting horizontally over the y-axis. And now we have to look at the third one. The third one is if you switch x and y. So it's down here. You may have done this before but not looked at it this way. You looked at doing the inverse of a function. The inverse of a function is if you take y equals f of x and you change it to x equals f of y. When you first learned about functions, you probably talked about, and I can't remember whether I've talked to you about this or not, but you looked at this being dependent on some other variable. The Did I use an example of temperature as you drill down into the earth? No, I didn't. If you look at depth and temperature, so if you're drilling miles down into the earth, the temperature goes, which way does it go? What happens? It goes up, right? It gets warmer as you go deeper down into the earth. You could look at the temperature as a function of the depth, or you could look at the depth as a function of temperature. In that case, it makes sense to do one of those two things, but not the other. Which one is dependent on which other one? Which one would you... Yeah, the temperature depends on the depth, right? First you're drilling down and then you measure the temperature, right? First comes the depth and then comes the temperature at that depth. So it would make more sense to look at the temperature as a function of depth. But you could look at it the other way around and say depth is a function of the temperature. Like if the temperature is, 32 degrees Celsius, what's the depth? I don't know. In this case, when it's just arbitrary, we could look at things either way here. We could look at numbers, one as a function of the other, y as a function of x, which is the usual way to do it, or you could switch it around. If you switch it around, and let's cross these off because these aren't the greatest functions to work with. I think we should use, what should we use here that makes sense? We should use, what was I going to use? You know what? I want to pause. So we're looking at this now. This is x as a function of y. This black curve here is y as a function of x. It's a square root, or it's a quadratic function. If you follow this point along here, and I have no idea where my point has gone. My point is off the screen. Where is it? There it is. Let's get rid of that for a second and get this point back within view. Go back here. If you look at this now, we're going to trace out the inverse of a function is switching the x and y values. Okay, we're going to trade the x and y values. Because you look at, now it's off my screen here, but x is a function of y instead of y as a function of x. Come on. Not that hard. There we go. If we switch the x and y values, now I've done it so they're right on top of each other. I'm having all kinds of issues here. If you do this, it's going to draw this here, right? So the 0.22 is the same point. We're starting from there, but if I draw this down to there, the point -1, -3, if I switch the x and y values, becomes the point -3, -1. I'm just trading the values. If I keep going with this, what's going to happen with that red curve there? It's going to turn around here, right? It's going to follow that, and we've got that point, well, pretty close to that point, somewhere in there. 0, -2. If I switch the x and y values, I get -2, 0. It's over there, right? You keep going here up to, it's not filling it in very nicely, but we get this, right? This point right here. That's where it meets again, because at that point, or pretty close to that point, 1, 1 stays the same, 1, 1. Okay, it's the same relationship there, and this keeps going here. This is the inverse. Have you drawn the inverse of a function in grade 11? You were probably supposed to.
Yeah, we did.
You did, right? What was that? How do you get that graphically? Algebraically, you switch x and y, right? The inverse of this is this, just switching x and y. What's the inverse graphically?